Imagine a tremendous gathering, played by a perpetual number of stars, planets, and moons, all playing together superbly. At any rate, there is one explicit fragment of this ensemble that has shocked space specialists for a seriously significant time frame: exoplanets. Exoplanets are ordinary planets that exist outside our planetary system, hidden away somewhere deep in the Milky Way. You might be surprised to find that, among the gigantic number of galactic objects, there are exoplanets so like Earth, so tantalizingly similar yet confusing that they might be our planet's divine twin. We plunge into the charming space of Proxima B, found just 4.2 light-years away. The James Webb Space Telescope is disturbing our journey for an understanding of these divine secrets. Imagine a second when your mind adventures across the huge vastness of our reality, the Milky Way, which is home to more than a quadrillion exoplanets. That is a number with 15 zeros. To place this number in context, if each of these exoplanets were the size of a grain of sand, we wouldn't simply fill the Grand Canyon. We would have enough to make another landmark on Earth, a Grand Canyon 2.0 that would extend for a huge distance. It is generally surprising that around 20% of these glorious bodies have been designated Earth-like as far as geology and air structure. That means there is a 1 in 5 chance of seeing a twin of our planet, and the story doesn't end there. Closed by these planets, there could be another quadrillion moons, rough satellites like our moon, trapped in a gravitational dance with their parent planets. If you somehow manage to ponder tracking down another body in space that harbors life, or could do so, the universe offers a flood of chances. Now that we have spread out the material of unimaginable scale, it's time to introduce the master-skilled worker, prepared to paint its complex nuances, the James Webb Space Telescope. This heavenly Sherlock Holmes, with its amplified central focal point displaced by customizable central focuses, beats even the most advanced optical instruments. We're not discussing any focal point. It's 6.5 meters in primary mirrors, 2.7 times greater than Hubble's. Imagine the best detail it can separate, even in the smallest blaze of a star billions of light-years away, and then analyze the nuances of orbiting planets. What makes the James Webb Telescope revolutionary isn't simply its seeing power, but also its highly advanced technology, including advanced sensors and spectrographs. These tools can do considerably more than simply observe. They can analyze and channel the remarkable light marks emitted or reflected by superb objects to decipher their air conditions, harmony, thickness, and even mass. Acting as a space researcher, they can determine whether a planet has water, organic compounds, or even oxygen. The James Webb Space Telescope has the ability to answer these inquiries, lifting it from a simple observer to a scientific genius. It's not just an advance over its predecessor, Hubble. It's more like a quantum leap. If Hubble's revelation stunned you, get ready for a genuine celebration of radiant discoveries. Just as we extended our look across the complex landscape of the universe, it's worth zeroing in on one specific star in the divine show, Proxima B. Since its discovery in 2016, this baffling planet has stuck out as a Shakespearean legend, full of unpredictability and problems, astonishing stargazers and anthropologists alike. What's the deal with all the fight? First of all, Proxima B is basically in our galactic area, just 4.2 light-years from Earth. To put it in context, if you could beat the universal speed limit and go at the speed of light, you would show up in just over 4 years. About the same amount of time it takes for your favorite program to fall into reruns. But let's dive deeper into why this class is so critical. We're examining a universe that stretches over 93 billion light-years from one end to another, so finding a planet so close and so uplifting for scientific exploration is like finding a gem in a pile the size of Mount Everest, a gem that potentially holds mysteries about existence itself. In the grand embroidery of the universe, Proxima B is a complex line, offering us significant hints that could rethink how we comprehend habitability and life beyond Earth. It's not just Proxima B's nearness to Earth that excites established specialists. but also the captivating signs that this planet isn't just Earth-like, but potentially Earth 2.0. Proxima B sits comfortably in what space specialists call the habitable zone of its parent star, where conditions are neither too hot nor too cold, but just right for liquid water to exist. Imagine waterfalls, meandering streams, vast lakes, and perhaps oceans as deep and mysterious as the Mariana Trench. But before we begin dreaming about visiting Proxima B, we should consider a couple of its peculiarities. Leading a single day on this entrancing exoplanet lasts a staggering 11 days. Imagine first lights that not only introduce a new day but unfold slowly, resisting giving way to afternoon, and sunsets that linger, creating bright hours that photographers long for. While it sounds idyllic, it also has significant implications for its climate and habitability. How would human biorhythms adjust to the patterns of light and dark on Proxima B? Would we really need to eat 3 or 4 times as much in a single day on that planet? Would we sleep the same way on this very strange world? The basic patterns of life, as far as we know them, would be simultaneously tantalizingly similar and frustratingly peculiar. It's as though nature is giving us a riddle wrapped in a riddle, testing our understanding of what makes a planet livable. You may wonder how we can gather accurate and reliable data about a world we've never visited. The James Webb Space Telescope delivers all its capabilities like a giant Swiss Army knife. It's more than just a telescope. It's a complex research lab in the vacuum of space. Thanks to its innovative technology, cosmologists not only observe planets but also examine them through a prism of scientific instruments that would make CSI labs look basic. Using advanced spectrographs, the Webb telescope can analyze the light emitted and reflected by these distant planets. Each element or compound in a planet's atmosphere absorbs or emits light at a specific frequency. By focusing on these patterns, scientists can perform a remote biopsy of celestial bodies, determining not only atmospheric pressure and density, but also the possible presence of compounds essential for life, like water, organic carbon molecules, and even oxygen. Space legal science is not just cosmology, it's space criminal science. We don't sit idly waiting for clues to come to us. We actively seek them, exploring the atoms and molecules that make up these complex worlds. The Webb telescope isn't just an eye in the sky, but a highly specialized research lab, investigator, and vast detective all in one. It allows us to turn our hypotheses and theories about alien worlds into methods to confirm or deny them, changing our understanding of what might exist beyond our blue dot. Right when you thought you had uncovered the most stunning layers of this galactic onion, the story takes an unexpected turn. Just like in any science fiction thriller, scientists using the James Webb Space Telescope received something surprising from Proxima B. A signal so astounding that it spread throughout the academic halls and social media. Named as a potential tech signature, it was an electromagnetic discharge so complex and intricately designed that it could indicate the presence of an advanced civilization. The collective heartbeat of humanity seemed to stop at the peak of a discovery that promised to reshape our view of reality. Could the signal be the actual proof that we are not alone in the universe? And just as quickly as it appeared, the signal disappeared without repeating, leaving behind not just a stunning silence, but also a maze of unanswered questions and bubbling hypotheses. Was it simply a transient cosmic anomaly, a random event, of infinite arrangement, or something else intentional, a coded message, or even a sign of extraterrestrial intelligence? The solitary mission cast a sad remnant of mystery over Proxima B, sparking wild discussion and speculation. Was it just a passing oddity, or is it part of a much bigger story, more perplexing than we can imagine? But wait, the tale of our cosmic exploration is far from over. The ink has not yet dried and new chapters are still being written. This time, it's not just conventional specialists, but Harvard researchers who are leading a shift in perspective. As we continue the search for extraterrestrial life, They are not satisfied with just studying the signals and anomalies we've discussed so far. They're upping the ante by turning the James Webb Space Telescope into a kind of giant night vision telescope. They plan to search for artificial light sources in both the dark and illuminated areas of distant worlds. We're looking at staggering possibilities, such as the chance of detecting artificial versions of cities glowing in the dark like brilliant specks. Imagine seeing the glowing light emissions. It could be a city humming with the presence of an advanced human civilization transmitting its glow into the vast oceans. As we continue to unravel the secrets of the universe, the quest for extraterrestrial life takes on new aspects. Beyond the immediate interest in Proxima B, our grand pursuit digs deeper into the vast new regions of space. This pursuit is driven by both technological advancements and a significant desire to understand our place in the universe. Advances in cosmology and space exploration have led to the discovery of various exoplanets with potential habitability. Instruments like the James Webb Space Telescope, methane or carbon dioxide, which, under the right circumstances, could suggest biological processes, are made possible by JWST. Beyond the fundamental discovery, its advanced instruments can measure the atmospheric composition of exoplanets, helping researchers identify potentially habitable worlds. The data collected by the intricate telescope could reveal the processes and dynamics of distant exoplanets, unraveling new insights about their environments. With our exploration efforts to advance, Proxima B continuously remains a key subject of inquiry, guiding us into the future of space exploration and the discovery of extraterrestrial life. As the James Webb Space Telescope expands our comprehension of distant planets, the pursuit of life beyond Earth has become a major focus of scientific research. The methods and technology we're using to investigate these exoplanets, like measuring their atmospheric composition, can provide the most direct evidence yet of whether they could support life. This quest is more than just looking for familiar environments that resemble Earth. It also considers the vast diversity of conditions that may unexpectedly facilitate the growth of life. The concept of discovering extraterrestrial life, or even just signs of life, carries profound challenges. It poses questions for humanity's future and our perception of our individuality in the universe, advancing our comprehension. Imagine discovering life's possibilities, that life has developed in other places, in conditions vastly different from Earth. Possibly, life on other planets has evolved to survive in extreme temperatures, toxic atmospheres, or a lack of water, environments we once thought inhospitable. These questions push the boundaries of the philosophy of biology and cosmology. The potential of Proxima B for habitability serves as a beacon in this quest. Despite the circumstances in comparison to Earth's, it represents a prime candidate for study. Even if life doesn't exist on Proxima B, the very possibility of habitability opens doors to exploring other star systems that could support life. As we go on to gather information from this faraway exoplanet, we are also learning about the broader universe, refining our tools and methods for locating life throughout the cosmos. One of the most exciting prospects is the likelihood of discovering biosignatures or technosignatures, indicators that life might exist at this time or that an advanced civilization could exist. While researchers are still careful when drawing conclusions from anomalous signals, like the one from Proxima B, the search for artificial light or other signs of technology could change our way of thinking about the concept of extraterrestrial intelligence. If we were able to locate cities or openings in distant planet infrastructure, it would open new avenues of inquiry, blending astronomy and the pursuit of civilizations beyond our own. This dynamic, ever-evolving research is driven by collaboration across many fields: astronomy, biology, engineering, and artificial intelligence. As technology continues to improve our scanning capabilities, our ability to scan the cosmos with ever greater precision will only increase. Already, new missions are being prepared to make use of the Webb telescope's capabilities, with upcoming projects aimed at investigating even more distant exoplanets and star systems. What implications does this have for the future of space exploration? As we expand our reach into the universe, we're confronted by an exciting possibility: exploration of a cosmic ecosystem, interconnected and teeming with potential for existence. With every new discovery, whether it's a distant atmosphere, a strange signal from a star, or a planet system, it facilitates our progress toward understanding our place in the vast cosmos. But with every answer, new questions arise. Questions that challenge our deepest assumptions about life, the universe, and everything in between. The search for life beyond Earth is not just about finding something familiar. It's about embracing the unknown, pushing the boundaries of our imagination, and acknowledging that we are part of a much larger, mysterious universe. The future of space exploration is unfolding before us, and it is brimming with opportunities to rethink everything we know about life, existence, and the cosmos. As we move forward, the discovery of another Earth or the signals from an alien civilization may not be just the end of one chapter.